Decision trees are a non-parametric supervised learning. This technique widely used for classification and regression tasks. The goal of this method is to create a model that predicts the value of a target variable. In other words, decision tree encodes a series of if-then-else rules. Each node in a tree contains a condition. Let's take a look at some advantage of decision trees. Decision trees is simple to understand and to interpret. You can easily visualize trees. Decision trees require little data preprocessing. You can deal with both numerical and categorical data using this technique. Cool! Decision trees are wonderful. Of course, decision trees has some disadvantages. Let's take a look at disadvantages. Decision trees can create overcomplex trees that do not generalize the data well. To overcome this problem, you can use some method such as setting the maximum depth of the tree, setting the minimum number of samples required at a leaf node, and pruning. Decision trees can be unstable. To avoid this problem, you can use decision trees within an ensemble. To show how to implement decision tree algorithm, I am going to use the breast cancer Wisconsin dataset. Before loading the dataset, let me import pandas. Import pandas spd. After that, let's load the dataset. df equals pd.read csv. Let me write the name of dataset. Breast cancer Wisconsin.csv. Cool! Our dataset is loaded. You can find the link for this dataset in the description below. Let's take a look at the first 5 rows of the dataset. df.heat. Here you go. This dataset consists of examples of malignant and benign tumor cells. The first column in the dataset shows the unique ID numbers, and the second column shows diagnosis. Let's say M indicates malignant and B indicates benign. The rest of the columns are our features. Let's take a look at the shape of the dataset. df.shape. You can see the number of the rows and the columns. Now, let's create the input and output variables. To do this, I'm gonna use the log method. First, let me create our target variable. Y equals df.log square brackets colon comma. I am going to select diagnosis column. Diagnosis. Let me convert this variable into numpy array. To do this, I'm gonna write values. Beautiful! We created target variable. Let's create our feature variable. To do this, I'm gonna use the drop method. X equals df.drop. Let me write the column names that I'm going to use when building the model. Square brackets, quotation marks, diagnosis, ID column. Lastly, let me write unnecessary column. Unnamed 22. To draw from columns, let me set axis equals 1. To convert a numpy array, let me set values. Cool! We have created our variables. Pay attention. Our target variable has 2 categories, M and B. Let's encode the target variable with label encoder. First, I'm gonna import this class from sklearn.preprocessing import label encoder. Now, I am gonna create the object from this class. le equals label encoder. Let's fit and transform our target variable. Y equals le.fit transform. Let me write y. Awesome! We encoded target variable. Before building the model, let's split the dataset into training and test set. To do this, I'm gonna use the train test split function. First, let me import this function from sklearn.model selection import train test split. Let's split our dataset using this function. X train, X test, Y train, Y test equals train test split. Let me set the variables X, Y, comma. To split imbalance, let me set stratify equal Y. For reproducible output, let me set random state equals 42. Cool! Our datasets are ready to analyze. Let's go ahead and take a look at how to build the decision tree models. First of all, I am going to import the decision tree classifier class from sklearn.tree import decision tree classifier. Let's create an object this class dt decision tree classifier. First, I want to use the default values, so I'm gonna only set random state parameter. Random state equals 42. Let's build our model with training sets. dt dot let me call the fit method. After that, I'm gonna use x train, y train. Awesome! We built our model. Let's predict the training and the test values with this model. Y train pred equals dt predict x train. After that, let me set y test pred equals dt dot predict x test. Cool! We predicted the training and the test values. Now, let's take a look at the performance of our model on datasets. To do this, I am gonna use accuracy score function. First, let me import this function from sklearn.metrics import accuracy score. Now, let's take a look at the accuracy scores for training and test sets. Train equals accuracy score y train pred. After that, let me set test equal accuracy score y test pred. Now let's print these scores. Print f quotation marks decision tree train test accuracies curly brackets train colon. To see only the first 3 digits, let me set dot 3f curly brackets test colon dot 3f. Here you go. The scores were printed. As you can see, the score on the training set is 100%, but the score on the test set is 95%. This means that our model has overfitting problem. Pay attention, the decision trees model learned the training set so well. So, it simply memorized the outcome. But the model cannot generalize. Note that overfitting happens when we have a complex model. To overcome the overfitting problem, we control the complexity of a tree. To do this, we have multiple ways. First, let's specify the max depth parameter, which controls the maximum number of levels. The default value for the max depth parameter is none, which means that the tree can grow as large as possible. We can try a smaller value and compare the results. To do this, let's copy previous code and paste here. Let me specify the max depth parameter. Max depth equals 2. Let's train the model. To do this, let's copy these codes and paste here. Now, let's take a look at the performance of this model. To do this, I'm gonna copy these codes again, paste here, and copy these codes, paste here. Here you go. As you can see, the performance on the training set was 100%, but now it's only 95%. It means that the model can no longer memorize all the outcomes from the training set. By making it less complex, we improve the ability of our model to generalize. But this tree has another problem. It's too simple. To make it better, we need to tune the model using different parameters. To do this, I am gonna use grid search technique. Let's import grid search from sklearn.model selection import grid search CV. Now I'm gonna create an object from decision tree classifier. dt equals decision tree classifier random state 42. Okay, now let me create a parameters variable which includes the values of the max depth and another important parameter mean leaf size. Parameters equals curly brackets max depth colon square brackets 1 2 3 4 5 7 10. If you want, you can write more values. It's enough these values in our case. Let's set values for the mean leaf size parameter. This parameter uses to specify the minimum number of samples in a leaf node. Mean samples leaf square brackets 1 3 6 10 20. Awesome. We specified the values of the parameters. To find the best parameters, I am gonna create an object from grid search. clf equals grid search cv. First, let me set our estimator dt. Next, let me write parameters variable. Parameters. To use all processors, let me set njobs 1. Beautiful. Our model is ready to train. Next, I'm gonna fit our model with training sets. CLF dot fit xtrain ytrain. Finally, to see the best parameters, I'm gonna use the best params attribute. To print, let me set print function CLF dot best params. When we execute this cell, you can see the best parameters. These are 5 for max depth and 3 for mean sample leaf parameters. Now I'm gonna predict the training and test set values with these models. Pay attention, we don't need to train our model again because after the best parameters are found, the model is trained. Let's predict the values of the training and test set values. Let me copy these codes and paste here. I'm gonna only change the model name. CLF. Here you go. The accuracy scores were printed according to best parameters. Notice that the score of our model on the training set is close to the score on the test set. In addition, both accuracy scores are close to 1. Awesome. So, we have found the best parameters and predict the values in the training and test set using these parameters. Decision trees are a non-parametric supervised learning method. You can perform both and regression tasks with decision tree algorithm. That's it. I hope you enjoyed. In this video, I talk about decision trees, how to implement this technique with scikit-learn. You can find the link for this notebook in the description below. Thanks for watching. Don't forget to subscribe to our channel, give a like and leave a comment. See you in the next video. Bye for now.